Hi guys, in this session I will discuss about hysteresis motor. We have an idea about hysteresis from magnetism chapter. Hysteresis motor is a single phase motor. Single phase power is fed to the stator winding and it rotates at synchronous speed. That's why this motor is called synchronous motor. The point to be discussed: the construction of the motor, working principle, torque, advantages, disadvantages, and application.
Actually, hysteresis motor is a unexcited synchronous motor. There is no DC supply used for excitation. In the rotor, there is no teeth. It is cylindrical type and made of ferromagnetic material. It consists mainly stator and rotor. Stator has two windings. One is main winding and other is auxiliary winding. In this image, a stator and rotor shown separately. Stator has winding but rotor has no winding, and it is smooth and cylindrical type. Now I'm discuss about the stator. To produce rotating magnetic field, main winding and other auxiliary winding is employed like other single phase induction motor. Sometimes shaded pole type construction also employed for produce rotating magnetic field. Here a image shown. In this image, some small black circles and some white circle shown. The black circle indicates the auxiliary winding and white circle indicates the main winding. Now rotor. The rotor is smooth cylindrical type and it is made of ferromagnetic material like chromium steel, alnico, etc. for high retentivity. Rotor of hysteresis motor has high resistance to reduce eddy current loss. The rotor is mounted on an aluminum R-bar. In this image, you saw the aluminum R-bar which is pointed by the green arrowhead. Here, the top, the magnetic material is pointed. Here, the shaft. Now, in this image, a loop is found. You all know about the loop. This loop is called hysteresis loop or BH curve. In magnetism chapter, we already discussed about this loop. If the area of the loop is more, the hysteresis loss will be more. If the area of the loop is less, the hysteresis loss also less. In hysteresis motor, the motor actually runs on the hysteresis effect. So in this motor, the loop is more or the area of the loop is more. Now I'm discuss about the working. When a single phase supply is fed to the stator winding, the rotating magnetic field is produced and cuts the rotor. According to Faraday's law of electromagnetic induction, eddy current induced in the rotor. and eddy current developed a torque which is eddy current torque. At the influence of magnetic flux, a hysteresis torque also produced in the rotor. When rotor is rotate and achieve the nearly synchronous speed, then the stator magnetic field and rotor locked with it. When rotor gets synchronous speed, the relative motion between stator and rotor will be 0 and the slip will be 0. So there will be no eddy current induced in rotor. At that time, rotor rotates only by the hysteresis torque. Now, we try to understand about torque. The mechanical power developed in the rotor due to hysteresis loss is given here. I am marking it. This mechanical power developed. The mechanical power developed is equal to hysteresis loss because the power developed by the hysteresis loss. Next, the torque produced due to hysteresis loss is here. This is the equation of hysteresis loss. We already know from magnetism chapter. This is the equation. This is the equation, and this loss developed the torque. Okay, next slide. Here Fr is rotor frequency, F is supply frequency, S is slip, Bmax is the maximum flux density, and K is the it's constant. Now, the hysteresis torque, which is developed in the rotor here, it is constant because when the motor rotates at synchronous speed, the speed is constant and the torque also constant. Now I discuss about eddy current and eddy current loss and eddy current torque. Here the formula of eddy current loss is given. We all know the formula, and it produces torque. The formula, I mark it this, and the torque developed by the eddy current due to this formula. Okay, I'm going to next slide. The equation of eddy current torque is here, and lastly we get from this equation TE is proportional to S. TE, that is eddy current torque, is proportional to slip. The eddy current torque is directly proportional to the slip. When the hysteresis motor get synchronous speed, the eddy current torque will be 0 and only hysteresis torque is present and run the motor. The eddy current torque assists the motor to start. We discuss about the advantages of hysteresis motor. In starting, we see that the rotor has no teeth and no winding. It is smooth, so there is no vibration and noise. Due to absence of vibration and noise, it operates for precision equipment where noiseless operation is required. It's suitable for high inertia load to accelerate and possibility of multi-speed operation by employing gear train. It has some disadvantages. The torque is low, the power factor also low, it available in small size. Due to more losses, the output of the motor is very poor. Lastly, I discuss about the applications. Due to noiseless operation, hysteresis motor is used for sound preparing equipments, high quality record players, tape recorder, electric clocks, teleprinter, timing devices, etc. Some images is here. You see that the sound preparing equipment, high quality record player, tape recorder, here electric clock, teleprinter, etc. I hope you all understand this topic. Thank you.